Hangman here, and welcome to my unbelievably clean apartment. As you've probably guessed already, we're going to be talking about something a little bit different in this video. The reason for this is about a week ago, I had an idea that I thought was pretty interesting, so I figured I'd share it with you guys. For those of you that are interested in theoretical physics and that kind of geeky thing like I am, you're probably going to find this pretty interesting. For those of you who are more interested in theological things like studying God or religion, that kind of stuff, you'll probably be pretty interested in this as well, especially in the ending. And for those of you who are interested in neither, go troll in the comments or something. I really don't care. Just do whatever. Before we get to my idea, we're going to have to open up with getting some kind of understanding of quantum mechanics. Now, it's nothing too complicated or advanced or hard. It's just the really basic stuff. So to open up, we're going to be talking about what's called the double slit experiment. In the double slit experiment, basically the plan was you take a little electron gun thingy, you shoot electrons at this electron blocking thingy, I'm using very simple terms here, and they go through one of two slits, either this slit right here or this slit right here. And once they go through those two slits, they hit this photoelectric paper, and the photoelectric paper records where the electron lands. And one electron went through at a time. So the electron shouldn't interact with anything else. It should just go through one of the slits and then land on the little photoelectric papers at some point. And so what the scientists who were doing this experiment were expecting was for about half of the electrons to land, around here after going through this slit, and the other half of the electrons to land, around here after going through this slit. So you'd have some electrons here, and no electrons anywhere else. To put this in more graphical terms, what the scientists were expecting to see as the results were the electrons landing in this pattern. One second. With the two little bumps here. Now those bumps should be the same size, I'm just horrible at drawing, but that's basically what they were thinking was going to happen. Instead what they got, and get ready for another horrible drawing, was this. One moment. That. Which, as you can tell, does not look a whole lot like what they thought would happen. This is what's called a wave function. Electrons are particles. Wave functions happen when a wave of some sort hits something. We're talking like the assortment of marks on the beach, if you were to be recording that, when the waves from the beach are hitting it, not when you throw baseballs at something. Electrons are baseballs, they're not waves. And yet, whenever they landed on this thing, the pattern that they made looked a lot like the pattern you get from waves. In order for this to have happened like this, the scientists knew that the electron had to have been interacting with something. And so, in order to double-check their experiment, they placed a poorly drawn detector, actually they placed a normal detector, I just drew it poorly, in front of one of the slits. This way, they would know when the electron passed through this slit, and when the electron passed through this slit. It was just to double test that everything in their experiment was going as they had planned. Now, once the scientists put the detector there, all of a sudden, they got this pattern instead of the wave function pattern. They got exactly what they would have expected from the beginning, which is really weird because the detector wasn't blocking either slit. It wasn't influencing anything really in the experiment except detecting things, which it's bizarre that would change the result, as you would think that was not expected. After a lot more experimentation and a lot of calculating and thinking and the scientists finally figured out what exactly was going on here. And before I tell you what that is, I'm going to need you to do something for me. This represents everything you think you know about reality. Now what I need you to do is I need you to go like this, and then like this, and then like this, and then like this. We don't touch that anymore. That is not true. You thought it was true. We need to ignore it now. Okay? Okay, glad we're through that. The reason we just went through that little exercise is because the moment the electron came out of this gun right here, all of a sudden, since nothing was keeping track of it and no particles or anything were interacting with it, the second it left this gun, it was in every possible place it could have been. It wasn't in one place. No, it wasn't in a single place that you would think that the electron would be. No, instead, if the electron had a chance to be anywhere between here and here, per se, it was everywhere between there and there. And then, after it was everywhere within, this area, once it went through these two slits, it didn't just go through one slit, no. It went through both of the slits, because it could have gone through either slit, and it was in every possible place. It went through both of them. And after the electron went through both of the slits, as before 5 minutes ago you probably didn't think was possible, it started repelling itself. Because electrons do that when they're near other electrons, and I guess it didn't realize that the other electrons were the same electron as it was. So all these little, I can't call it a piece of an electron because the whole electron was in every place, but all these little electrons that are all the same single electron started pushing on each other after they passed through this point. And that's why it spread out like crazy in the end. And then, the second it hits this photoelectric paper, all of a sudden we're keeping track of where the electron is again. It's interacting with something. And so instead of being in every possible place from here all the way up to here, it picked one point to be in. Somewhere between there and there. Yeah. Once they added the detector, though, this went a little bit differently. The electron left the little gun, and then it traveled over to these two slits. But once it got to the two slits, it had to make a decision, because all of a sudden, something was keeping track with it again. Once it got to these two slits right here, the electron realized that either it could go through the right slit or it could go through the left slit. It couldn't go through both of them because something was watching it. It had to only be in one place at a time because that's how we think reality works. And so the electron would only go through a single slit, and after it exited that slit, it started existing in every possible place again. But that didn't seem weird to us because we were expecting it to land somewhere in the possible range of like here to here if it went through this slit, or here to here if it went through this slit. And so once it hit this thing, it collapsed back down into one point, and we didn't notice that anything weird was happening because the electron didn't interact with itself going through two different slits in this case.